This is lesson 2.2, enlargements and reductions. So we'll start with our definition of scale. Scale is a ratio of the measurement of a model to the measurement of the actual item. So for example, if you were looking at a map of British Columbia, obviously the map that you're holding in your hand is not the actual size of the province. So what they've done to make that map is looked at what BC actually looks like and then scaled that down so that can fit on a piece of paper that you can hold in your hands. So in the map that you're looking at, the distance between, let's say, Vancouver and Victoria is really only going to be a couple centimeters on the map, but then it will give you a scale at the bottom of the map that might say like 1 centimeter is equal to like 500 kilometers or something like that, so that you know it's proportionate, like the distances are proportionate to each other, so you have an idea of how far away cities actually are from each other. Another example might be if you have something really tiny like a molecule or an atom. If you have a photo of what that looks like, it's been enlarged a lot because like the human eye can't see a molecule, but we've taken like a scientific photo of it and enlarged it so you could see what it looks like. So we just kind of talked about both of those, enlargements versus reductions. So enlargement is when the model is bigger than the actual item, so like the molecule example, or if you had like a stuffed animal of a ladybug, for example, that stuffed animal is of course bigger than what an actual ladybug looks like. A reduction is when the model is smaller than the actual item. So that would be like if you had a toy airplane, that's of course smaller than a real plane, or when we have maps, like you're reducing the size of British Columbia down to a map that you can hold in your hand. So how do we write scale? You write it as a ratio that has a colon in the middle here, those two dots. And the number that goes first is always the size of the model. And the number that goes second is the actual size of the item. So for example, you might have a scale that's 5 centimeters to 1 centimeter. So you always write the model size first, and you always include units. But if you see a ratio like, let's say 1 to 4, and there's no units included, then it's assumed that the units are the same. So if you ever seen them not written, it's just that they're using the same units. When you're given a scale, if they have different units, then always convert one or both of the sizes until they're written in the same unit. So if you were given this ratio, 5 centimeters to 1 millimeter, then change one of these so that they're in the same unit. So if I change my 5 centimeters to 50 millimeters, now these units are the same. So always make sure they're the same. You have to always make sure to reduce the values until one of the sizes is 1. So if you were given a scale of 12 centimeters to 240 millimeters, well, the first step would be to convert one or both of these units so that they're in the same units. So I changed 240 millimeters to 24 centimeters. And then you can reduce, these both can be divided by 12. So if we divide both by 12, we've got 1 centimeter to 2 centimeters. So it's kind of like we always want to reduce our fractions to lowest terms. We also always want to reduce our ratios to our lowest terms, or until one of them is the number 1. Doing some examples. So if we're given 1 centimeter to 1 millimeter, again, model always goes first. So this means that on the model, 1 centimeter is actually equal to 1 millimeter of the real life item. So we're going to convert the units so that they're the same. It makes sense to convert 1 centimeter into 10 millimeters instead of the other way, like instead of converting your millimeters to centimeters. So now our ratio is 10 millimeters to 1 millimeter. And now that they're the same units, it's a lot easier to compare to see if whether it's an enlargement or a reduction. And so since the model size, the first number, is bigger than the second, then that means it's an enlargement. So the actual size is smaller than the model size. In this example here, we have 2 centimeters to 1 kilometer. So the first thing we can do is reduce these values just to make it easier on ourselves. So if we divide both by 2, then our ratio becomes 1 centimeter to half a kilometer. And we know from our last lesson that half a kilometer is 500 meters. So we can do our first unit conversion to say that 1 centimeter, the ratio is 1 centimeter to 500 meters. But we still have to do one more unit conversion so that they're in the same units. So we can convert 500 meters to 5,000 centimeters. And I just showed the work over here. If we know that 1 meter is equal to 100 centimeters, then we just multiply both by 500 to figure out how many centimeters 500 meters is. So now that they're the same units and one of the numbers is 1, we can figure out if it's an enlargement or a reduction. This would be considered a reduction because the model size is a lot smaller than the actual size. So it's been reduced. So an example might be like the map of British Columbia. In this example, no units are given. So like I said before, if no units are given, it means they are already using the same units. And since this scale is written as, we always know that model goes first and actual goes second, then this has to be an enlargement because this first number is larger than the second. Couple more examples. So a little trickier than what we've done so far. If the scale is 1 to 5 and the model is 12 centimeters, then what is the actual size? So again, the model is written first, the actual is written second. So since the model number is smaller than the actual number, this is a reduction. So therefore, we know that if we know the model's 12 centimeters and it's going to be smaller than the actual, we're going to be getting larger when we're trying to figure out what the actual size is. If our scale is 1 to 5, we take our scale of 1 to 5, and we have to figure out what do we have to multiply it by so that we get this 12 centimeters. We get the number that we're already given. How do we make our model become what we're given here? Well, it's an easy calculation because it's just 1. So we just have to multiply this by 12 so that we get our 12 centimeters for our model on the left side. If we do it to one side, we also have to do it to the other. 5 times 12 gives us 60. So then that tells us that the actual size is 60 centimeters. So I also wrote it out in words here. 1 centimeter on the model is 5 centimeters on the actual. So if the model is 12 centimeters, then the actual has to be 12 by 5, 60 centimeters. And always finish by I like doing a therefore statement, the 3 dots, and then like circling or putting a box around my answer so that I've communicated my solution well. This is the last example, and this actually comes directly from your book, number 6B in the homework, because it's written a little bit complicated. So I wanted to show you what it's actually asking for. So you want to calculate the actual size if the model is 4.9 centimeters and the scale is 1 to 28. And also write your final answer in millimeters. So we'll start with our scale. We know this is a reduction because the model number is smaller than the actual number. We don't need to convert anything because the units aren't written, which means the units are already the same. And 1 is one of the numbers. So now we want to rewrite the scale that we're given so that it has the model size that we're given, which is 4.9. So how do we make the model size become 4.9? We just have to multiply it by 4.9. If we do it to the left side, we have to do it to the right side. So then I just did my quick math over here. 28 times 4.9 gives us 137.2. So we've just rewritten the scale. These are the same proportions, but we have rewritten it so we can get this value here. The scale is given in centimeters. Even though it's not written, they tell us that the model is 4.9 centimeters. So we know that this scale is talking in centimeters. And so we just figured out our answer is 137.2 centimeters, but we need to have our final answer in millimeters because that's what it's asking for. So we have our answer, we just convert it to millimeters by moving the decimal place 1 to the right because we're multiplying by 10. That makes our final answer 1,372 millimeters. In other words, that many millimeters is equivalent to 49 millimeters based on the model and the actual values given here. So that's how we deal with scale, enlargements, and reductions.